Today we're going to talk about the shell method. But before we get to that, let's talk about shells. And no, we're not talking about the seashell ones. We're talking about the shape, the shell. It is basically a cylinder with a hole in it. And we can see in our regular calc class, we have one around the classroom. It looks like this. Now that we have an idea what a shell is, let's get to the shell method. Like the disk method, we're finding the volume of a solid of revolution. Instead of finding infinitely many disks, we're finding infinitely many shells using rectangles that are parallel to the axis of revolution. In this case, the solid is formed by the function revolving around the y-axis within a given interval. We are forming shells using the rectangles within the function. By adding the volume of individual shells, we will find the volume of the solid. Now let's take a look at this shell and its variables. So H stands for the height, P stands for the distance between the axis of rotation to the center of the rectangle, and W stands for thickness. Let's just clarify again. So H stands for height, P stands for distance between the axis of rotation to the center of the rectangle, and is also used as the average radius. And W stands for thickness, and usually is in terms of dy or dx. In order to find the volume of the solid of revolution, we must find the volume of the shell. To find the volume of the shell, we must subtract the volume of the outer cylinder by the volume of the inner cylinder. And to find the volume of cylinders, we use the cylinder equation, which is volume equals pi r squared h. In order to find the volume of the solid of revolution, we must find the volume of the shell. To find the volume of the shell, we must subtract the volume of the outer cylinder by the volume of the inner cylinder. And here's the equation. And to plug in the variables, which is the two r's, the radius of the outer cylinder will be p plus w over 2, and the radius of the inner cylinder will be p minus w over 2. And just to clarify again, P is the distance from the axis of revolution to the center of the rectangle. And W will be the thickness of the cylinder. And now you must be questioning, where did the W over 2 come from? Well, W over 2 is just half the thickness of the cylinder. And now let's just talk a little bit about the radius of the outer cylinder. The radius of the outer cylinder is P plus W over 2. And the radius of the inner cylinder is P minus W over 2. Now that we know the equation of the volume of one shell, let's simplify it. After we multiply everything out, we're going to get 2 pi times P times H and times W. The W over 2 will be canceled. And the P stands for average radius, the H stands for height, and W stands for thickness. To find the volume of the entire solid, we have to add up all the volumes of the individual shells within the interval. We can find this sum by integrating the volume of the shells through this integral. The Py stands for the average radius, the Hy stands for the height, and the Dy stands for thickness. And ta-da! Now we have our equation for the volume of the solid.